So we'll discuss the second unit today. This is based on finite automata. So basically finite automata is a machine which has different states and we can transit from one state to another based on what is the input. To represent finite automata, there are 5 parameters that we need to specify. So if you can see here, the first parameter is Q. Q here indicates the set of states. So all these states are included here. Sigma is the alphabet. So all the symbols which are there in the input string will be alphabet set. Then the set of transitions which can be represented in the form of transitions, or we can specify that in the form of a state diagram. Next we have the initial state Q0 and the final state. So these are the 5 parameters that you have to specify when you are designing a finite automata. Okay. Next we will have a look at few examples of these automata. Now, there are 2 types of finite automata: deterministic finite automata and non-deterministic. Okay, so first we will look at the questions and then I will simultaneously explain you what are these type of automata. Okay, now both these type of automata are represented by all these sets of 5 parameters. If we have a look at deterministic finite automata called as DFA, for any input symbol, the transition of the state is known and there is no ambiguity. So for here, Q0 transits to state Q1 when input A is received. Similarly, state Q1 transits to state Q2 on receiving input B. So there is a fixed transition, there is no decision that the machine needs to make. As opposed to this, in non-deterministic finite automata, which we called as NFA, here if you see Q0 can transit to Q1, it can also transit to Q2 when the input A is received. Now here there is an ambiguity. Now should Q2 transit to Q1 or should it transit to Q2 when it receives the input A? Such type of machine is a non-deterministic finite machine. So this is called as an NFA. Now since we always want that the machine should be deterministic, because we cannot leave the ambiguity on the machine to decide when to transit and when not to transit. So first we'll go through the numericals on converting from non-deterministic finite machine NFA to deterministic, that is DFA. So if you see here, we have this NFA which is given to us. So we'll have Q, alphabet set, transition, initial state and final state. To obtain the DFA, we will find Q1 dash. So this Q1 dash is basically the set of states which DFA can contain, and this is nothing but 2 raised to Q, or the power set of given states Q. The sigma or the alphabet set remains the same. So for DFA also it is same as NFA. Similarly, the starting state for DFA is also same as what is given for NFA. We will have change in the transitions, so we have indicated it by bar, and there will also be change in the final state, so this is also F dash, and there was change in the set of states that this DFA can contain. So these are represented by dash here, and these 2 parameters remain the same. Okay, so now let us try to solve this question. It says we have to convert the given NFA to DFA. The given NFA here has Q states which are Q0, Q1. So that is, this NFA can have only 2 states, either Q0 or Q1. Next is 0 or 1, which are the input symbols. Next we have transitions. So these are the transitions which are given to us. It can be given in this table format, or you can be given a state diagram. Next is the initial state, which is Q0, and the final state is Q1. So this is how it is represented in the 5 tuple format. Now the transition table here, it states that Q0 on receiving input 0 can transmit to either Q0 or Q1. So therefore this is NFA. Similarly, Q0 on receiving 1 will transmit to Q1. The arrow here indicates that it is the initial state, and star here represents that it is the final state. Now Q1 on 0 is phi, that means there is no transition that is available. Q1 on 1 gives Q0, Q1. So this is about the question. Now let us start converting this given NFA to DFA. Now as we know, the symbol remain the same. So we have 0, 1. So for DFA also we have 0, 1. The initial state also remains the same. So here we have Q0. Next we had Q bar, which is the set of states that this DFA can contain. So this DFA can contain the power set of Q. So I have Q0 and Q1 in Q. So we also include phi here. Next is Q0 alone, Q1 alone, and Q0, Q1 combined can be one state. Okay, so this is about the language, initial state, and these are the only states that the DFA which we are constructing can have. Okay, now how to get the transitions, that I will explain. Okay, now we start with the transitions. So here we have the first transition. So transition is delta dash because this is for the DFA. Now this will start with Q0 because the initial state of NFA and DFA is same. And then process this with all the input symbols or all the symbols in summation. So first we'll process it with 0 and then we will process it with 1. So Q0 is processed with 0 and 1 both. Okay, now how do I get the answer here? You will have to refer to the given table. So what does the table give you? Q0 on 0 gives me Q0 Q1. So Q0 with 0 gives us Q0 Q1. So this is how you have to write. Next, finding the transition of Q0 on 1. Again have a look at the table. Now Q0 on 1 gives me Q1. So here I will write Q1 as the answer. So this is completed for the initial state. So I have done or found out the transitions for the initial state. Now what we'll do is these new states which we are getting, we'll start processing these states. So the first state that we will be processing is this Q0 Q1 because that is the new state that we have found. So this new state has the name Q0 Q1. Now Q0 Q1 will again be processed with all the input symbols. So in the input symbols we have 0 and 1. Now where do I get this answer from? We get this answer from the table. But now we have to process two things. We have Q0 and Q1 both. So I will first process Q0 with 0, take a union with Q1 and 0. Okay, so now where do I get these transitions from? From the given input table. So Q0 on 0, if you look in the table, this gives me Q0 Q1 union. What do I get from Q1 0? We get a phi. So when I take a union, the final answer that I get in this step is Q0 Q1. Okay, and as soon as you process this Q0 Q1, we can also put a tick here to understand that this is processed. Now processing Q0 Q1 with input 1. So this is Q0 with 1 union Q1 with 1. Where do I get these values? Get this from the input table. Q0 on 1 Q0 on 1 in the given input table is Q1 and Q1 with 1 is Q0 Q1. So taking a union here, we will get the answer as Q0 Q1. Okay, so this is processed. The second processing step is done. You have to sequentially process the new states which are getting generated. Now here the next state is Q1. So I will process Q1 here. So the next step will have processing of Q1 with both the inputs 0 and 1. Okay, now Q1 with 0, I can find that in the table, which is 5, and Q1 with 1, I can again find that in the table, it is Q0 Q1. Okay, next Q0 Q1 is the new state that is generated, but it is already processed. Next again it is Q0 Q1, which is also processed. Here we have 5, so we need not proceed further. Next we have Q0 Q1, which is already processed. Now since all the new states that were generated are processed, this process will stop. And now I can rename these states to construct the table. So for example, I call this Q0 as capital A. Next step I had Q0 Q1, I call this as B, and in the next step I had Q1, I call this as C. So when I construct the DFA table, so now these transitions which I have obtained are for DFA. I'll convert this or write the corresponding DFA table. So first I will specify all the states here. It is not mandatory to rename these states. You can also call them Q0, Q0, Q1 and so on. Okay, because these are already present in the power set. So the states which are generated are not out of this power set. There can be less states which we get, but they will be out of these states which are listed in the power set. So A on 0 and on 1, what are we getting? So A on 0 we are getting Q0 Q1, which we have renamed as B, and this is Q1, which we have renamed as C. Next B on 0 we are getting Q0 Q1, which we have renamed as B, and the next one we are getting is B again. Phi here and B here. So this is the final output which you should get. This is in the form of table. You can also draw the diagram. So A is my initial state. How do you define the initial state? We have already told that Q0 is the initial state. Now how to find the final state? All those states which contain the final state of NFA will be the final state in the DFA. So what was the final state in the given NFA? It was Q1. Now I will look out for all those states which contain Q1. So B contains Q1, this will be the final state. This contains Q1, this will be the final state. So B and C are my final states. I indicate that by marking a star in the table. In the diagram, A on 0 gives B, A on 1 gives C, B on 0 gives B, and on 1 also it gives B. So I write a slash. C on 0 gives phi, so no transition will be there. C on 1 gives B, so C on 1 gives B. So this is the state diagram corresponding to the given DFA. This I have marked the initial state. How to mark the final state in this diagram? You have to draw concentric circle. So B and C are my final state. I will draw concentric circle here. So this will be the final state in the diagram. So this completes the entire numerical of converting the given NFA to DFA. Now please take this as the second question and convert this given NFA to DFA. What you will have to do is based on this given NFA transitions, first draw the NFA table as it was given in the previous question. Then convert this to DFA. I will quickly show you the answer here so that you can verify. So here we have the first set of transitions. Now I'll move to the next page, and here you have the final answer.